Welcome students, we are given this question: solve x raised to the power y is equal to y raised to the power x. Now before we could solve this particular question, there are a few things we need to take into consideration. Now x cannot be equal to y. Now if x is equal to y, say for example x is equal to 5 and x is equal to y, it means y is also equal to 5. So you get something of this fashion. So y 5 raised to the power 5 is equal to 5 raised to the power 5. Or if x is equal to 15, you get and y is equal to 15, because x is equal to y, you get 15 raised to the power 15 and 15 raised to the power 15. So you got nothing to solve when x is equal to y. So that is a very important observation you have to make. Now why am I specifying it at the beginning? Because this is going to come back haunting us if we were to permit this particular case, x is equal to y. So I'm totally annihilating this case and taking the problem for x not equal to y, and then I want to have x and y to be element of real numbers. Now you will know why am I picking up R to be my domain. So having set up the problem for these conditions, we will go on to solve this question. Now foremost, let me just take the value for y to be equal to 2. I would like to show you this part or this side of the solution. If I were to take y is equal to 2, then I would have something like this: x raised to the power of 2 is equal to 2 raised to the power of x. Now if you were to graph this quantity or this function, the graph was going to be looking something like this. Right? An approximate graph. Now if you were to graph 2 raised to the power x, then the graph would, because it's an exponential graph, the graph would start somewhere over here, and it will hit the point, and then it will hit the point, and then it will move up. This is 2 raised to the power x exponential function. So if you can clearly see, there is a point of intersection over here, and there will be a point of intersection over there. So there are actually 2 real solutions. If I were to take the equation in this fashion. Now extending a bit further, say for example if I were to take y is equal to 3, then I would totally have so let me show you that phenomenon. Now in this case it's going to be x, in place of 2 I'm going to have 3, and in place of 2 it's going to be 3 raised to the power x. So this is what I've got. Now if I were to draw the graph of x cubed, let me show you that. The graph would flow something in this fashion. Now if I were to draw the graph of 3 raised to the power x, then the graph would start off like this, make an intersection and go up, and there would be a point where this line would intersect and move up. So there would be another point of intersection. You can check that out. So even in this case, there are 2 real intersections and 2 real solutions. Now why am I showing you all these things? I'm showing you all these things because I would want to take my x and y to be element of R. So having mentioned this, I would want to move on. Now clearly if you were to see the given equation, the equation given is x raised to the power y is equal to y raised to the power x. Now if I were to take x is equal to 2 and y is equal to 4, then clearly you can see 2 raised to the power 4 is equal to 4 raised to the power 2. So x is equal to 2 and y is equal to 4 is a solution. Now why is this important? It is important for us to observe that y can be written as some constant times multiple of x, because in this case y is 2 times x. So what I'm going to do is, to solve this question, I'm going to assign the value for y. So let y be equal to some p times of x. Now this would mean, if I were to take this as 1, so I can rewrite 1 to be as, so x raised to the power, in place of y it's going to be px, in place of y I'm going to substitute px, and there's going to be a x. So this is how it looks. Now x raised to the power p times x, I'm going to rewrite this as x raised to the power p, the whole raised to the power x, which is equal to p times x raised to the power x. Now I'm able to do this because from the law of indices, a raised to the power m times n is a raised to the power m, the whole raised to the power n, which is equal to a raised to the power n raised to the power m. So by this I can do this alteration. Now what I'm going to do is, I'm going to take raising both the powers, both the terms to the power of 1 over x. So raising both the terms to 1 over x, I would get rid of this power and I would get x raised to the power p is equal to p times x. Now clearly I can move the x down, so this would give me x raised to the power p over x is equal to p. I can move the x to the numerator. I would get x raised to the power p times x raised to the power negative 1 is equal to p. I can rewrite this as x raised to the power p negative 1 is equal to p. Now I want to get the value of x, so I'm going to raising both sides to the power, I want to get the value of x, so I'm going to raise both the sides to the power of 1 over p negative 1. So this would give me x raised to the power p negative 1 raised to the power of 1 over p negative 1. This is p raised to the power 1 over p negative 1. Now p negative 1 gets cancelled, giving me x is equal to p raised to the power of 1 over p negative 1. This is my x. Now to get my y, what I need to do is I need to substitute over here. So if I were to take this as 2, therefore 2 can be rewritten, y is equal to p times of p times raised to the power 1 over p negative 1. This can be rewritten as p raised to the power, this is 1 and this is 1 over p negative 1. So I can rewrite it as 1 positive 1 over p negative 1, which is p raised to the power p negative 1 positive 1 divided by p negative 1. Negative 1 positive 1 gets cancelled, giving me p raised to the power p over p negative 1. So this is what I get for y. So I have x, which is p raised to the power 1 over p negative 1, and I have a y, which is p raised to the power p over p negative 1. Now you can substitute the values for p, but p cannot take the value equal to 1. Now if it does, let's go back over here. It means y is equal to x, which means this will contradict to the problem, very fact that x cannot be equal to y. Another fact, if I were to take p is equal to 1, I would be dealing with an undefined quantity. I don't want that. So what I want to do is, if I were to take p is equal to 4, or you pick a value that you like, if you were to take the value of p is equal to some 3, then you will have x is equal to 3 raised to the power of 1 over 3 negative 1, which is equal to 3 raised to the power 1 over 2. So this is nothing but square root of 3. This is x. Now if you were also for y is equal to p is 3 raised to the power 3 over 3 negative 1, which is equal to 3 raised to the power of 3 over 2. So this is nothing but 3 raised to the power 3 raised to the power 1 over 2. I can rewrite it like this. So which is nothing but 27 raised to the power 1 over 2, which is nothing but root of 27. So if you were to substitute these values, then you can clearly see that x raised to the power y, which is x is root of 3, and y is root of 27. This is equal to y raised to the power x. My y is root of 27 and my x is root of 3. Now clearly you can see that root of 3 raised to the power root of 27 will be same as root of 27 raised to the power root of 3. Now I can show both of these quantities are same. Now I'm going to start off with root of 3, and root of 27, I'm going to write root of 27 as 9 times 3. On the right side I'm going to rewrite, as I just mentioned to you, 9 times 3, and this is raised to the power root of 3. Now this is rewritten as root of 3. Now root of 9 times 3 is root of 9 times root of 3. I'm not going to touch this for now, let it be there. And this is going to be root of 3. Root of 9 is 3 times root of 3, right? So this is rewritten as root of 3. This is raised to the power of 3, and that is in turn raised to the power of root of 3. I can do that by the law of indices. Now this is nothing but root of 3 cubed, so it's going to be root of 3 times root of 3 times root of 3, and that is raised to the power 3. Root of 3 times root of 3 will give me 3, and that's nothing but 3 times root of 3, which has to be raised to the power 3. So let this be there, and let me come back to this right hand side. This is 9, root of 9 times 3 is going to be root of 9 times root of 3 raised to the power root of 3. Now root of 9 is 3 times root of 3 raised to the power root of 3. Now check it out. What do you got? 3 times root of 3 raised to the power root of 3. And what have you got here? 3 times root of 3 raised to the power root 3. So they are one and the same. So the left hand side is equal to right hand side. So just by mere algebraic properties I have shown you that. Now on the other end I have the value. I would want to show you one more thing. So this is for the value that we have just got. Now if in case, so let me write down the value for x. Now x is equal to p raised to the power 1 over p negative 1, and y is p raised to the power of p over p negative 1. So this is the value that we have just reached, right? Now there are two straightforward solutions that we have found. In fact, just one solution we know. X raised to the power y is equal to y raised to the power x. Now when x is equal to 2 and y is equal to 4 and 4 and 2, this is clearly a solution, right? 16 is equal to 16. Now the question comes is, if I were able to make a choice by trial and error method, and if I decipher the value for x and decipher the value for y, how am I to zero it in for the value p? In other words, how am I to figure out the value of p that produces the values x is equal to 2 and y is equal to 4? You follow what I'm trying to get at? Now it can be easily done from this particular point. Now from here what I'm going to do is I'm going to take this as say 3 and take this as 4. My value of x I've already found out, it's 2, but our contention now is to know that what value of p will produce that 2. So that is our point. So I'm going to start off by saying 2 is equal to p raised to the power 1 over p negative 1 to begin with. Then I'm going to take ln both sides. So that would give me ln of 2 is equal to ln of p raised to the power 1 over p negative 1. Now I know by formula ln of a power b is equal to b times ln a. From here I'm going to rewrite this as ln 2 is equal to 1 over p negative 1 times ln p. This is what I've got. Now I can cross multiply. That would give me p negative 1 times ln 2 is equal to ln p. So let me take this as 5. Let me look into 4. Consider 4. So I've got a y is equal to, in fact y is 4, so let me place the value 4. 4 is equal to p raised to the power p over p negative 1. Now I'm going to take ln both sides. Now when I take ln both sides, I would get ln of 4 is equal to p over p negative 1 times ln p. Now I'm going to cross multiply. I get p negative 1 times ln 4 is equal to p times of ln p. Now if I were to take 6, my ln p, now just check this out, the value for ln p. Ln p has got a quantity in this fashion. So what I'm going to do is I'm going to substitute there. So put 5 in 6. So p negative 1 times ln 4 is equal to p times, in place of ln p I'm going to substitute p negative 1 times ln 2. Now you can clearly see that this p negative 1 and p negative 1 can be cancelled, and I can rewrite this as ln 4 over ln 2 is equal to p. Now I can rewrite ln 4 as ln of 2 squared divided by ln 2, and I can rewrite ln 2 squared as 2 times ln 2 over ln 2. Now removing logarithm, I get a value 2, so p is equal to 2. So this is how I can achieve, or I can arrive at the value for p. Now that just to show you that the value of p is really 2, in other words, when p is equal to 2, it will produce the solution x is equal to 2. Let me just show you the output. I've got x is equal to p raised to the power 1 over p negative 1. If I were to take the value of p to be as 2, so this is going to be 2 raised to the power 1 over 2 negative 1, which is nothing but 2 raised to the power 1 over 2 negative 1 would give me 1, and that is going to give me 2. So clearly x is equal to 2 over here. And on the other hand, my y value is p raised to the power of p over p negative 1. My value of p is 2, so it's going to be 2 raised to the power 2 over 2 negative 1, which is nothing but 2 raised to the power 2. 2 negative 1 will give me 1, which is nothing but 2 squared, which is equal to 4. So y is equal to 4. So this is a beautiful question, but there are a few restrictions we need to apply to arrive at the solutions, students. So if you have found out anything else apart from this, say if you were to come across some complex solutions, you please place it in the comment box, or even if you have come across a different type of method. Of course, there is another method by Lambert W function. I did not place it here, and that also produces solutions for this particular equation.